Good day everyone, and welcome to DataMine OpenPit webinar series part 2. My name is Terence Ralevala, a mining engineer from DataMine, South Africa, and I will be taking you through this webinar. The name of this webinar will be, this project will be Ultimate Pit Design using the Auto Design tools on Studio OP. I am not alone. I am with Beatrice Sato, a mining engineer from DataMine. She's going to be the co-organizer on this webinar. Just to quickly take you through what Haja has covered with you on the previous week. She actually took you through the webinar on Studio NPVS or NPVScheduler, where you were able to define what is ore, or to define your economic model, where you defined what is ore and what is waste, and you also defined some economical inputs, such as the associated costs like mining and processing costs. You also defined the plant recovery formulas. You under the ultimate pit, you define the ore rate per year, or ore production rate per year. You define the discount rates, the slope regions. You also ran the ultimate pit process using Lech-Grossman algorithm, and after that you selected the ultimate pit based on NPV. So on this exercise, we're going to take over from there. We are going to design the ultimate pit using the pit shell, or the nested pit that Haja has selected as the ultimate pit based on the NPV. So what we need for this exercise, we need the topography, the block model. The block model we got from Haja. We also going to need the slope regions. From Haja, I mean like from the NPV, the one that Haja has chosen as the ultimate or the optimized block model. And we are going to use the slope regions. I'll show you right now. And we are going to use the ultimate pit shell to actually guide us to obtain the optimum pit. This ultimate pit shell, this is what's going to guide us when we do the design, so that we don't mine more waste or compromise the size of the pit. So this is going to guide us, and we're going to, on the Geotech information that we have, we're going to use this as the Geotech information. And we have different types of materials like fresh rock, soil, weathered rock. We have ore, and they have different overall angles. As you can see, for soil we have actually around 25 degrees, and we have for fresh we have 55 degrees. We have 45 for weathered. You can see that for fresh rock and ore, those are the strongest rocks. So we have actually a gentle on what you call a steep angle compared to soil, which is actually relatively loose material. And we are going to have bench heights of 10 on soil. We're going to have bench heights of 20 on fresh and ore. Weathered and soil going to have 10 meters bench height. So on the face angle, we're going to have 30 degrees for soil, and 60 for weathered, and 70 for fresh and ore. So the beam width is going to be 4.1 and 4.2 for ore and weathered respectively, and also fresh and ore we're going to have 6.7. So our soil will be on zone 1, fresh will be on zone 2, weathered will be zone 3, and ore will be zone 4. So I want to quickly show you what Hajar the results that Hajar obtained on the previous webinar when she worked out the optimum pit shell. So this is just the optimum pit shell and the optimum pit block model that we are going to use for this design. If I can just hide here, you will see that this is the pit shell, and if I can show, this is actually the block model that the optimum block model from the from NPVS. So here, as you can see, some blocks are actually showing corners at the edges of the wireframe, of the shell wireframe. So this basically means that NPVS looks at the centroid. Anything that falls within the centroid of any block that its centroid is inside the pit, it takes it as part of the optimum block model. So anything that lies outside is actually discarded or recognized as waste or not optimum to be mined, or in that case, so it doesn't bring value. So I will quickly switch to the OP, where we're going to design our pit, or our final pit. So what we need to do, just go straight to our setup ribbon. This is where we are going to start defining or start setting up our pit. Excuse me. So here on manage, this is where we are going to define our pit name. So we are going to call this pit webinar part 2. So I'll just save here and continue. Here on surface topo, this is where we are going to add our topography. So I'll select the topo. So here it's just telling me that there's one intersection found, so I'll just continue with this wireframe because I've used it before and it works. So I'll actually assign that topo to this pit here. So I'll save and close. So now I'm going to define my block model. I'm going to add a copy and select the block model that I got from the NPVS, and here it gives me an option to assign my fields. So I'm going to take my zone as the slope regions, and I take my copper and gold as my grid. And now I can assign the block model to my pit, and then I save again and close. So here it actually allows you to validate your block model. If there are any abnormalities, you can actually see it here and rectify. So I don't see any abnormalities. I just continue. So here under phase, this is where you can define your phases if you want to create pushbacks. So in this case, I'm going to work with one pit and or one phase. That's the final pit that I'm going to design. So I'll continue and go define my benches. So I'll use the block model to actually create my benches. I know that my blocks are 10 by 10, so I want most of my bench heights will be 10 meters, and I'll just maybe double bench and get maybe something like 20 meters on other rock types. So I'll apply this and save and close. Okay, you can see after applying it gives me the bench number. It gives me the bench height, the crest, the toe, and the level. So my level will be on the crest. So now I can save this and continue. So after saving and continue, I can move on to design. Under design, this is where I can now start defining my slopes. So you can define your slopes using manual. You can define them manually. You can also define them using a boundary strings, but for this exercise we're going to use a block model. So you can see that after selecting the block model, it actually selects the zone as my region ID, and this is what I've defined under setup, that this is going to be my slope region. So here under default is anything that will be outside the block model, so I can just put 89, relatively vertical. So I'm going to make it 0 and 0 on my standard and my catch beam. And here on the face angle, for region 1 is actually my soil, so I'm going to put 30 degrees, and these are going to be 10-meter benches. So I'm going to say 4.1 here under catch beam and standard beam. So for my region 2, under region 2, this is where my fresh rock is. So I'm going to actually put 70 as my face angle, and I'll put 0 for standard beam so that I can have a double benching on this bench. This is where I have 20-meter benches, and 6.7 for the catch beam. So region 3 is actually weathered, so I am going to use 60 degrees phase angle, and I'll use 4.2 for my standard beam and 4.2 for the catch beam. Region 4 is my ore, so here it's 70 degrees, relatively competent rock, and I'm going to have a 0 standard beam, beam, and I will have 6.7 beam width, catch beam width. So in this case, I've done defining my my slope regions, and now I want to have I want to specify that for every second bench I want a catch beam. So if I come here and select catch and then I update, you can see that I have every second bench I have my catch beam. So I can save this and close. So now my slope regions have been defined. Now I can go to shell contours. So under shell contours, you can this is where you can generate the surface that you want to guide you when you do the design, so I don't go outside the optimum pit or lose a lot of ore because you are designing a very small pit. So now I'll just import the surface that I got from Azure, and this is what I have right now. So from this I can just come here and generate the bench contours. So you can see I get something like this. So you can use your splines and just to make actually smoothen the surface or your contours here. So now I'm going to continue and save this and close. I'll just leave it as is, and I'll save and continue, and then I come to ramp layout. So under ramp layout, this is where you can define your ramps. For example, I'll call this one a test 1, and I'll keep it at 5. Okay, let me maybe make it 10 degrees, and sorry, 10%, and the width maybe make it 15. So it can be counterclockwise or clockwise depending on what we want to see. So designing up, so you want it to actually start from the bottom and going up. So I can select any point where I want the road to start. This is just a demonstration. I'm going to design the roads straight from the auto design tool. So right now I'm going to jump straight to my auto design, where I'm going to design. Sorry, I didn't save. You can see that it says do I want to save? Yes, I want to save. And jumping straight to auto design tool, this is where we are going to actually design our pit. So here I have options. Options to actually use this. It's always advisable to use this contours to actually use it as your base when you actually are creating a pit. But for this exercise, I actually have one string that I have, a base string that I'm going to use. So I'll just drag it here, and I'll do this. I'll hide the contours, and so that you see my string, my base string. So this is the last bench or the lowest point of the contours. So most of you, I'm sure you're familiar with this tool here, the auto design. So this is basically the design direction. There's top down, bottom up. There's also this is where I can create my new roads, adaptive roads, and this is where I can edit my adaptive road. You can see that I have a test road that I've created under the ramp layout. So if I want to use this road, I can switch it. If I don't want to use it, I can switch it off here, or I can delete it here. I can move the start point. I can move the elevation, the end elevation, the switchbacks as well, the taper distance as well. I can play around with that, and also the gradient and all that. So, and you also have the new fixed road here that you can create or edit it here. So we also have conditioning. Okay, this is if you want to switch on and off the topography. Here you have the planning model, you have the contours, like I just switched off the contours. Now let me maybe show the planning model, and then this is if you want to mark the strings above topo. You want to add the rim between you want to add the rim to design string when making design surface. I can combine the design surface with topo and all that. You can also evaluate. So conditioning, this is where you can actually do a lot of things, more especially when you have slope regions. If you want to define the most, for example, the blending distance, when you want to adjust your blending distance, that's the transition, or if you want to ensure the smooth transition from one region to another, you can define that distance here. And you can also define your maximum width change or berm width change and the maximum slope change. You can also do the berm tempering here. And the advanced option, this is where you can change the colors of your strings, and you can go to road gradient side, like your pit inside, your pit outside, and stuff like that. So right now I'll quickly go back to this string here. So what I'll do is I'll just select this string, and then I'll add this string as a constraint string, since this is my base string. And you'll see that when I recalculate, it's either I click here or I can just come here and recalculate. And if I want to make the design surface, I can do that here. So now let me quickly recalculate. You see that road is in here, the road that I have created here, and ramp layout. So I don't want this road actually, so I'll just quickly delete this road. I'll create my own road when I'm done with the design. So I can bring in, under pit data, I can bring in the shell that I got from the NPVS, just to see how I am doing with this design. So right now I can see that I might be losing a lot of ore this side here, so I need to make this pit bigger on this area here. So what I'll quickly do now is I can just display my contours just for my shell contours and remove the shell, and you can see that yes, I'm actually leaving a lot this side. You can also display the block model or the planing model there, just to see where you actually losing ore. So if I can go to plan view and maybe go to sheets here and block model, maybe I want to see this guy as blocks and I want to clip that. So okay, let me change the legend here. I want to see it using litho. So there's a legend that I have for this webinar, and I'm going to show that legend here. And now I'm going to say okay, and you can see that I am actually losing a lot of ore this side. So the best way is actually to extend my pit towards this side. So this side is actually waste, where I have weathered the rock and I have soil as well. So I can quickly clip this guy here, clip using benches, and I can go to the last bench, and if I zoom in, you see that I have something like that. So if I move up quickly, let me go back to plan view, you can see that in these areas where I'm actually losing out ore, but I know that I'm still going to put my ramps here, so obviously my pit will extend a bit. And if I just go up, I can just look for the west areas where I think I'm losing too much, or now I can hide this and use my and use my let me just use a single color here of black, maybe will do. Okay, yes. Okay, so I can see that I'm losing out here. So moving up, I can still make up this because by using my roads. So I'll just continue. You see, in these areas here, in this area here, you can see that I'm getting something like okay, if I bring in my block model, you see that I'm actually going to lose ore in this area. Even if I put in the road might just come around here. It won't be able to reach these areas here. So what I'll do is I'll quickly do this, change my design in this area here by actually adding this string as a constraint string. Okay, you can see that my constraint string is just the same as my contours, so I can quickly go to sheet and change my constraint string color for visibility's sake, and make my line at least 5 scale, and symbols change it to fixed and make it 9 here. Then I just apply. So I can extend this guy here and make him by inserting a curve here. So let me quickly do that before we run out of time. ICS, so I can start my curve here and end it there. So you see I have something like that, which I'm happy with, and then I can say done. When I recalculate, you see that my string just went there. My two string went there for this next bench. So if I unclip this, you see that my pit is slowly growing towards this side here. If I can display my block model quickly again, you see that there's a lot of ore here that I can actually retrieve or gain. I'll get it back. So I'll just quickly move this guy here and clip again, and then plane view. Then I move up. So as I move up, you can see all. I can see all there. So I just need to add this guy here, and ICS, insert the curve. Let me start this curve here. Yeah, I'm going to get a little more waste, but sometimes it depends on what you want, because you might find that it's worth it for you to mine this waste in order for you to get this ore here. So how do I know that this is ore? It's because I've checked it here. And I can see that there's ore there. So I can recalculate again, and I can MPO this guy here quickly. I just want to move this guy here a bit so that I don't have wavy areas or wavy corners. So I can do this DPO and delete this guy. I don't need him. MPO, can move this guy a bit, can move that one there as well, and then I recalculate again. So if I move up, you see that still there's something that I'm still losing out here, and it's O actually. So I can move down a bit and move these points here towards this side. Sorry, I have to select this guy NPO, and I can do this depending on how you want to actually mine this even more. So I'll recalculate again, and then I move up and up again, so I can adjust this guy here as well, and MPO. Sorry. Okay, yes, it's okay. No, sorry. I want to add this guy here as the done. Okay, as the constraint string. Now I want to select this guy here and MPO this guy here, because I see a corner here, and I can insert curve ICS in this area here until here, so I can do this, and then done, and I can MPO this guy here. Oh, sorry, Control Z. Can select this guy here, move him a bit, calculate, and when I move up, so at least I managed to get some of that off. So now I can unclip this and actually look at my pit. So display my planning model. So you can see that I still have ore outside a bit there, and there, and I can hide this guy. Let me now insert the ramp and see how it actually changes. It actually changes the size of the pit, depending on, obviously depending on the size of the road as well. So here I'm going to create a new road. Sorry, let me hide this guy, new, and I'll call it HR1, whole road 1. So I'll make it 10% grade percentage, and I want it to be 15 meters. So clockwise. Okay, no, let me make it counter clockwise. Yes, no, clockwise. Okay, so the entry distance for now, make it 0, just to check how it goes. Yeah, all right, so I have something like that, and I want this road to actually maybe submit somewhere here on this part here. So I am going to move the start point by coming here, edit adaptive road, and I can just move it here. Okay, So now it's above that guy there. Okay, it's it depends on where you want it to end actually. So I just want to play around with it, and so we can see. I think it's doing what I want a bit there. Yes, so I can just leave it there, and in this area here I can quickly add a switchback just for it to, assuming that my plant is actually this side. So I'll add a switchback here. I'll add a switchback in this part here, and let me mark the strings above topo so I can see. Yes, so I managed to reach the top part of the pit, so I can move the end elevation here. Okay, let me add the switchback again. I think I removed my switchback. Add a switchback here. Yes, so it worked. Alright, so I'll quickly make a design surface. Just wanna click down there, and I think I'm happy with what I have right now, and I can quickly, okay, I can just change this by adding entry distance of 20. Let me start with 20 to see the change there. See, I have something that's coming nice there, and 40, apply. Yes, so I'm satisfied here. So what I'll need to do is maybe I can add another ramp here that's going towards the, assuming that my dump is this side here. So I will come here and look at this guy here. When I go to data properties, I can see that this guy is actually at 1222. So I can go to tempering here and look for that guy here and add a flat road of 50 meters maybe, and then I recalculate, so I get something like that. I can hide my constraint strings for now. Going back to task. Okay, sorry, auto design. Then I hide my constraint strings. So I want to design a ramp going out that way. Okay, this changed my ramp a bit, so I'll move the start point for this ramp HR1. So move it Okay, take it back a bit. Oh, sorry. So it's there. Okay. Yeah, I think it looks good now. So I can start another road here on this flat road here and call it HR2. Okay, let me remove the contours cause for good visibility here. And here I'm going to add a new road and call it HR2. HR2, same width and gradient, and I choose my start point to be there. Oh, sorry. Oh, okay, sorry, I didn't change the direction. I wanted to go that way actually. So I can delete, let me quickly delete this guy, HR2, and create HR2 in this direction. Choose that point. Yes. So I can add the switch back here in this area here, or this area here on this HR2. Edit, add a switch back, then I add the switch back there. So everything looks good. But now the entry distance, I need to put in the entry distance so that I can access this guy here and make it okay, let me make a ditch surface so that you can see what I'm talking about. You see, like, it's just a road with no access here. I can quickly do that by adding the entry distance there on HR2 and make it 40. Apply. You see, now I have a nice area there to join HR2 from the pit bottom. So I can do this and make it here. You see, like now I have this same level here. So I can actually, if maybe my dump is actually that side, I can just add another switch back there and then it goes that way. But now with time I'll just leave it here, and I'll just actually end my HR2 there. Oh, okay, maybe let me add a switch back here quickly. HR2, then I add a switch back here. Okay, that's the wrong position, and I edit there. Yes, I'm happy with this. So I can end elevation there. Yes. So this is my pit. I just need to smoothen it up here. So I'll quickly show my constraints. And I'll delete this constraint here, constraint string here, and add this one here as the constraint, so that I can fix this guy here, this wavy part here. So I'll do that by adding constraint, and the string must be selected, and DPO these points here. think now MPO. I think now good to go. Done, and then recalculate. See, now I have fixed this guy here, but there's still more that can be done there. And this guy here as well, I can move these points here. Excuse me. Just to take that road back to shape, recalculate. Looks good. And can do this here as well, and add this as a constraint string. And I delete points here. Just to get something smooth, let me recalculate and see what brings me. Yes. So I can leave all this, and let me make a surface and see, make a DTM and see how it looks like, and hide all the strings. Okay, hide the strings. Alright, so you can see that I have something like that, like this is leading me towards the dump, and this one is leading me towards the plant. So I can combine this with my topo and recalculate and make a surface. So, and then I don't want to see the strings. Okay, so I have something like that. So now I can quickly show the picture that I have from NPVS. You can see that I can get a section here. Go to view, okay, so I can edit this interactively, and then I see the difference between my NPV. My NPV is the blue one, sorry, the green one, and my actual design is actually the one that you see, this reddish color here. So I can edit interactively, and then you see throughout the pit that somewhere it was getting bigger. Sometimes due to the rows you have to mine more waste than blend, and this is how it is. So, and this marks the end of this webinar. Thank you very much everyone for attending and your attention, and I will start to take questions if there are any, and then we close. Just a reminder, on the 3rd of September, JP or João Pedro is going to take us through the webinar part 3, where he's going to do the strategic pushback generation on NPVScheduler. Please register and attend so that you can follow all these sessions. Thank you very much for your attention, and here are our contacts if you have any questions or further questions.